Alright, should be making a video, draft physics video, DraftScience on YouTube and such. But you should know that, if you're here. Anyway, comments, useless comments. And then a presentation of some kind regarding theorizing on reality. And who's qualified to do it, and what's a quality argument, what we're really after, and how do you get there? You know, I mean, what's the goal? The truth? Oh, yeah, maybe that should be the goal. And the only way to get there is with facts, I would argue. Anyway, the guy with the fair faucet hair wearing the turtleneck sweater called someone else a dork. You also have Tarzan hair, or, you know, He-Man, or even like Hulk Hogan. Lots of people had long hair. Loser. Fuck you. Frank the Spank. He calls himself that. I mean, you know. But, I mean, why don't you just call yourself stupid loser? Because that's what you are. You got his look from the funeral home. Yeah, show your face, chicken. Shit. I mean, these people are just such cowards. I mean, they talk all this shit from their little hiding places. No balls at all. Pathetic, ballless, tiny little dicks. Anyway, if you believe anything matters. So just, you know, see, this is part of the problem, is there's just so many people who are crazy on planet Earth. And they're just so delusional, so full of shit. What's your view on John Wheeler's one particle theory? Well, I think it's just quite obviously idiotic. Yeah, one particle. Yeah, we're not going to make opposite things out of one particle. Just really, realistically, not very likely. I mean, you could say you have a triangle you start with, and then you put a bunch of triangles together and you make a circle. You know, it might be possible, but that's not his theory, obviously. I ask because I have discovered the whole number mathematical image, who the fuck could care, of the universe as described by Pythagoras. Well, who cares again? I mean, if you think that's going to explain all the phenomenon we see happening in the universe, you're just so full of shit. There's a ton of experiments you have to explain. Your stupid formula isn't going to explain them. It's not going to explain how it happens. I mean, the fact that we know kind of basic things, like energy has to go in for energy to come out. Duh. You know, if that's your formula, yeah, guess what? You're not going to surprise anybody with a brain. I am presently patenting this work. Good luck with that. And would like to share what I have found with you. Do you have an email? I mean, this is just so stupid. It's in the description box in the video, the email address. I mean, you can't figure that out, but you've figured out how the universe works. I don't think so. And again, so what? Yeah. So yeah, email me your stuff for what purpose? For me to what? Critique it? Okay. But it's going to be easily defeated as any explanation for charge and magnetism and gravity. So figure out how you can explain those three things, and then maybe you have an argument to make. But until you're doing that, I'm not terribly interested. Yeah, let me delete crap. Okay, hey, could it be there's more momentum within our universe? Well, yes, there's more energy in it, clearly, just because the energy they're not accounting for. So clearly there's energy that makes planets move into each other and moons circular and all that kind of crap. All that stuff has to be caused by some kind of energy. And conventional physics, you know, passes the buck, just says, we're not going to deal with the energy thing, we're just going to call it geometry. Bent geometry makes it happen. No energy required. And then they have a thing called a virtual photon to explain magnetism, and they call it virtual because they have no way of accounting for where the energy comes from. Where did the photon come from? Because no energy is burned. There's nothing producing it. So clearly there's energy in the universe which conventional physics is completely clueless to. Which makes the universe expand faster and faster. Well, you can believe that's happening. They only draw that conclusion based on redshift and their interpretation of what causes redshift, and that interpretation, I would argue, is nonsense. They think redshift happens while the light is traveling, which is idiotic. Well, no, I mean most of it. Commonly, let me put it that way, it's caused at the source moving or the receivers moving. And I would technically say the redshift they're seeing in the universe is merely because when light travels long distances in the universe, it hits little transparent atoms and it travels through them, and those atoms have a direction, and that direction is imposed, shifts the color. So there is no expanding universe. There's just the fact that there's redshift caused by other things. They really don't have any other evidence of any expansion. They have no evidence that things are actually moving further apart beyond redshift. So, again, these are such superfluous. They're tangential subjects in physics. I've sort of made it clear. What I'm arguing, what I first gave you was a gravity theory, then it became a unification theory. But it really isn't a theory of origins or any of this other crap. I don't give a shit where the universe is going or where it's been. I'm trying to describe how it works. Period. And the rest of these questions to me are so fucking uninteresting. Anyway. You know, there's one good thing about your videos, especially when you talked about your explanation of the bar pulled by gravity. Right, so I basically pointed out how you have to use more energy to jump, let's say, over a tortoise than you do to fall off a cliff. Like, falling off a cliff is a lot easier than jumping over a tortoise. I basically said it's harder to go upstairs than it is to go downstairs. That's the argument I made. Okay, and he says you'll never fail at embarrassing yourself. So I'm embarrassing myself by arguing that it's harder to go upstairs than it is to go downstairs cases on planet Earth. That's how gravity works. You will require more energy to go up the stairs than it will be required to go down the stairs. Yeah, that's how it works. God, you're an idiot. It's just the way it is. When you're, when you're not, if you're not in a conservative relationship to gravity, then it won't be conservative. So when you're going up and down, there won't be any energy conservation. It won't take as much energy to go down the stairs as it took to go up the stairs. I mean, you're just too fucking stupid. And these people are so arrogant. They're so stupid, and they're so arrogant. And so he gets 3 approvals for that idiotic comment, basically denying the basic function of gravity. That if you're going to do an experiment and say, look, it's a non-conservative, gravity's a non-conservative field because it takes more energy to go upstairs than it took to go downstairs. That's not a rational argument. Okay, you're an idiot. A new game show, Spot the Freemason. He. I don't know what the fuck that's about. Shalong. I mean, jokes that I can't even get. I mean, fuck. You're an idiot. The ether is all around us, and you demonstrate it with what evidence? Again, you can't cite a single experiment. You can't leave a link to your incredible proof. No, you've got nothing. We live in an electric universe. I mean, more just nothing talk. Electric exactly how? Electric goes from atom to atom. That is, energy is conveyed through a conductor. Electricity can't function without a conductor. And even when it makes a plasma, whoa, plasma. Well, what's really happening is the cathode is burning. The burning means atoms are coming off the cathode, and they're creating essentially a conduit, a wire for the electricity to pass through, a conductor. The plasma is is dense with atoms, and it's the atoms that are allowing electricity to pass, and that's it. There's nothing, there is nothing without doing that, without actually shoving matter. Now, there's absolutely no evidence that Venus ever shot lightning bolts to the moon or any of this other bullshit, that it created conduits for this electricity to travel through. You people are just so full of fucking shit. Funny thing is that on one of Ken Wheeler's videos. Ken Wheeler doesn't like the electric universe, guys. You are a fool. You live in a delusional world. Right. I'm rubber, you're glue, crazy fuck. So, Garrosh Hellscream. So, you have a weird name, you have a weird icon, and then you'll go around talking fool and delusional. This demonstrates this planet is covered with completely sick fucks. Your brain isn't working. It's just the truth. You have no capacity to recognize reality, to get shoe and book, to recognize the difference. You're an idiot. Colossal fucking kook. Alright, so, I figure I will do some, what do you call these things? Yeah, what do you call when you put things in boxes and connect the boxes? Flow chart? Maybe that's what it's called. But we'll do that anyway. We'll do a bit of flowing of the charting. So let's start with the basic thing, the basic concept, the E equals mc squared kind of thing. We have this concept of energy, right? And this is important. I mean, it's, E equals mc squared. It's this whole idea that energy is what makes everything happen. And it's really simple in the sense that you're kind of taught, and it's not incorrect, that there's two kinds of energy. There's this kinetic kind, we call kinetic, and then a kind called potential. Now, I would argue the kinetic kind is the kind that's sorry, potential. Well, I don't know how to fix that. We'll just make it something like that. Okay, so so the kinetic kind we get. So that's all the stuff moving the speed of light. So the forces, the things, even bent space. Bent space moves at the speed of light. So you can think of it as bent geometry, but it's kind of weird to think that the geometry is changing at the speed of light. I mean, that sort of indicates, well, it's got to be kind of like photons. It's got to be kind of a thing moving. It can't really just be space bending. But anyway, we'll let that go for the moment. I mean, if you want to believe in this stupid ether crap, yes, you can make the whole thing out of little bits and have the, but it's just so pointless to put a bunch of little bits and say I can move each little bit and they hit each other, when it's so much easier to just say the single bit just moves the speed of light. I mean, it just, why complicate it with a bunch of useless stuff? And especially when you start saying that the thing going this way is creating some kind of energy going this way, when that's not happening. I mean, photons aren't doing that. Photons radiate nothing. They are radiation. I don't know how people can get that one so wrong. There's no way photons can have vectors of stuff going this way and vectors going this way. It's just retarded because they never go anywhere and they never do anything. Ever. So why would you say there's a force doing this and a force doing that, when obviously there's no force doing that, because the only thing we ever detect is the photon hitting a thing in the direction it's moving. None of that force stuff ever affects anything, ever. Anyway. Ever. Ever, 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 ever. Okay. So the kinetic stuff is... So we can just say this is all the stuff going the speed of light. So I don't know exactly how to... So we just say speed of force. Okay, so that's all the stuff. Kinetic is the stuff still doing the speed of force stuff. So that means it's all the stuff that's like a photon. So it's the virtual photon that physics talks about, the force carrier for magnetism. and it's the force carrier, the mechanism of gravity. It's stuff moving the speed of light, the speed of force. And clearly photons, the electromagnetic spectrum, all the radiation in the electromagnetic spectrum is all of this kinetic force. So it's free, it's liberated force. So yeah, that's all that needs to be said. So when the force is free, independent, in its most elemental form, it's this kinetic stuff moving the speed of force. Potential, I mean, I wrote this down earlier, now I've kind of forgotten the flow. But potential energy is, let me see if I have my cheap version of my diagram here somewhere. Might have it here. No. Let's see. Oh, it might be this page here. Sorry for the brief interruption. Don't go about your business. I'll be back shortly. I mean, I know I did it somewhere. It's funny. Well, it's not really funny. It's curious. There we go. It's this piece here. It's always, sorry, technical difficulty, we call it. Alright, so how I did it earlier was, alright, so potential energy, yeah, see, I reduced it to mass in a direction, and I did that because that's what it ends up being, mass. Okay, so what you have to understand is if you take this kinetic force and you trap it, that is, you have it interact with a piece of matter, what that will do is cause the matter to move. And what basically is happening when the matter is moving is that the force has been put into the matter. It's trapped in the matter. Its direction is trapped in the matter. And that direction ends up being mass in a direction. So mass in a direction. Yeah. So it's a piece of force, and this has, so the kinetic ones are just the little bits, but they have mass. They can impose momentum. So clearly a photon has to have some kind of mass because it's imposing momentum when it interacts with something. And the potential energy is just that same stuff, okay, that it has direction, so it has a vector of direction, and which can be anywhere, and that vector of direction is essentially what we recognize as mass, in the sense that for something to impact us, it has to have momentum, movement, and depending on how much movement it has, and that is how many bits it has to move, it will be more massive. So you can sort of get that it obviously takes more little force bits to move something light than it takes to move something big, heavy, that has a lot of other vectors. So when something has mass, a lot of mass, it means it has a lot of trapped energy. There's lots of things. And so if you're going to change it, it takes more energy to make a change to its inertia, to what is has already established by existing its state. So as I've pointed out before, we're doing all kinds of relative motion. We're moving around the circumference of the Earth, and the Earth is moving around the Sun, and we have all kinds of motion. So our mass has a bias. That is, more of the force that we have trapped, that we have stuck in us, is going in one direction than is going in the other direction, the opposite direction. And that means you have a velocity in a direction overall. And we all have that, and it's constantly changing our vector, our net vector. So, so all you're really doing to give something mass is changing the bias of its force. You're making a bigger bias. So even though a bullet doesn't have a great deal of mass in terms of its atomic weight, if you give it a strong enough bias, it'll behave as if it's an elephant in terms of its pressure it can impose when it interacts with something. Very small, but very a very dense elephant. And so it's really just about the bias of that mass. And so there's only so much bias a light thing can have. If it's only got 10 bits in it, it can only have a bias that's 9 to 1, where something that's much heavier can impose a much greater amount of energy because it can have a bias of 9,000 to 1, because it just has more elements to be in bias. Alright, so this got more wordy than I think it needs to be. So the real the word that needs to be understood is trap. Okay, so that's all. Is that there's two kinds of energy. There's energy that's freely moving the speed of light, in the sense we see it go from point A to point B, like photons, like gravity, like magnetism. And then there's potential energy, which is really just a form of mass. Okay, in the end, it's just the collecting of force in traps. So let's just understand it can be circular, or the trap can be square, it doesn't matter, it's a trap. The energy stays in the object, it doesn't go to point B, and that's sort of the critical thing. The only thing you can really do in this universe in terms of changing it is take something that was going someplace and stop it from going there. Now you've changed not only this, but you've changed the force too. So there's two effects to that action. When you make a change in one place, you automatically make a change somewhere else, because there was a destiny that thing you changed had, and that destiny won't be realized. And that's the nature of gravity, essentially, is you're absorbing energy. By absorbing it, it doesn't get where it was going, and it induces gravity. All right. So as soon as you say the word, there's little subtle complexities to all these subjects, because it's not, the gravity you create isn't the gravity you experience. I guess I have to pause this video because the groundhog is back. Jesus. What do I do? What do I hit to do that? Control R. Alright, I should be back. Gravity. So the gravity you create by interacting with something isn't the gravity that is your fall into. So you add to gravity of something by having a relationship to something. So if this was going to be gravitationally connected to this is adding gravity to something that might be added out here. Okay, it's adding more mass and creating more gravity at one specific point here. If the pencil wasn't there, there's a certain amount of gravity. With the pencil there, there's more gravity. So things create gravity, but it's after they've already been affected by gravity. So the gravity you fall into is the gravity created by the objects, other pieces of matter. So the ground essentially under me created the gravity that I fall into. I don't fall into the gravity I make. I fall into the gravity something before me made, something closer to the center of the earth. That mass between me and the center is the mass. Well, it's actually me and the whole diameter of the earth, but anyway, that mass is what I fall into. And it's, you could argue the same is true of magnetism in a way. The magnet doesn't ever feel the force it creates, so magnets don't smell their own farts, kind of thing. What they're doing to the world, they don't experience an effect of that. They can only experience what something else does. So the idea of energy is just movement. You can have movement that's free, okay, and that's the stuff moving at the speed of light, and the movement that is confined is the movement of matter or something collective, and the collective is based on some kind of net movement. What do all the pieces together add up to? So it's like you're just putting a little membrane around a bunch of fish or cats, or it doesn't really matter what you're fencing in, and the fence is movable, and so wherever the cats move, the fence goes with them. So it's always a net democracy. The majority wins in terms of the direction, and it'll be decided by how many cats jumped into the fence at what direction they were going when they jumped in, and that'll decide where the fence is going. So, see, I just didn't, I want to do this thing so you can have the simple version, and then you have here's the real details that are a little more complex. Because what we're really arguing, or what I'm really going to get to, is that the universe really is this simple. You can think of it as lines. You can have a straight line from point A to point B, okay, and then you can have a more complicated line from point A to point B, a slower line, where you have a lot of distractions and you go a lot of other places. So now you've changed the time it took for you to get from point A to point B, and by changing the time, you've changed the effect. You can sort of understand that if somebody shoots a gun and it takes 10 years for the bullet to go all the way around the planet, and it goes through all kinds of weird things, and it finally hits somebody on Earth 10 years later, you could, it's kind of understand that, it didn't get to point A to point B in the same amount of time, and so things were very different than if the bullet would have hit somebody 10 years ago. And then as I'm sort of arguing here, you can have going from point A to point B, and you got trapped in a cul-de-sac, so to speak, and you could spend 10 million years just going in circles before you get to point B. Or you can be going from point A to point B, and you get totally distracted and just end up at point C. You never get to point B. You go to point C. And that's what's happening in the universe to this stuff moving the speed of light. It can just take one of these alternative routes, one of these options. So if it's free force, it can go straight and unobstructed. And as I was sort of pointing out, that the light argument with photons traveling through billions of light years of empty space, that they are probably going to hit little atoms that are in space, and those atoms are going to be usually things that are transparent, and they'll be transmitted through those atoms, and that will create some slowing down, some disruption that will change their frequency, stretch it out, redshift it. If it's coming towards us, if the thing is moving, the little atom. So if the little atom is moving the opposite direction, which would be the likelihood, you're more likely to hit things moving against the motion that you have, then it's going to be moving away from you, so to speak, as the photon's going through it, which is going to change it's the amount of time it takes to get to you. It's going to stretch the frequency. All right. Anyway. And then you have the trap, and then you have the diversion. So energy can be trapped and diverted is probably the way to say. You can say one of these, anything that slows it down, you could call it a trap. It's just that it's catch and release. So sometimes it's not trapped for very long. So you could argue that a pane of glass is trapping the light because it's slowing it down by 40%. So in a sense, it's trapping it before releasing it. The first photon in is slowed down, and all the rest are slowed down, so it all stays the same as its output, but there was a retardation in the fact that the light didn't get from point A to point B as fast as it should have. It would have if it had gone a straight line. So really the only change you have in the universe is being created by these functions. And the real point would be is that if you imagine a universe just full of these vectors, so this sort of fits with quantum field theories, where if you just take all of pixels in space, so if you just take it and think of it as a computer screen, and it's a bunch of little pixels, the whole universe can just be pixelized into a bunch of little locations. And all you're saying is each location has a bias, okay, a directional bias. And that would represent these little force bits. That would represent the fact that the whole universe is just made out of energy, and it's energy that can be free, going in straight lines, or energy not going in straight lines. Now, I wouldn't say it goes in a curved line. I'm just saying it's not straight in the sense that it goes straight this way, and then it goes straight this way, and then it goes straight this way, and then it goes straight this way, which means it didn't get anywhere, didn't change its overall location over time. And that's sort of the key to this argument, is that that's the trap of the energy. So the idea is if the universe was made of that, if that's this quantum field theory, you could see that two things could hit each other, and if they missed each other, the universe would look like this, right? And if they hit each other and reflected, the universe would look like this. So there'd be absolutely no way to tell the universe where everything missed each other from the universe where everything hit each other. The two outcomes would be identical in terms of the outcome, the result. But if we do this subtle thing, and likewise with the, I might as well draw it a more complete picture, likewise with this idea of two things coming in at angles, you really, the output, so these two come in, the output is going to be the same whether they miss each other, they hit each other. You know, if they take a right turn or they go straight through, you couldn't tell the difference if they all looked alike. So the real point is that if you do change your understanding a little and say, well, what if, you know, these little bits do have something different about them, then you could understand that if an electron force hit a proton force, that they would reverse direction in this manner, which does look different. Now the universe does look different, right? The red bits were going this way and the black bits were going this way. Now the red bits are going this way and the black bits are going that way. That's a change you can see. So if you do polarize the force, just like we know the matter's polarized, the electron-proton dichotomy, or whatever you want to call it, the oppositeness of that. And clearly, likewise, in this example, it also becomes, you know, change becomes apparent if you just polarize the interaction. Say there's two types of energy, then you can understand the universe changes quite dramatically. And this would be the right turn I've been talking about. And then you could just have 4 of those and you end up back in the same location. So it's kind of sort of obvious. You can also just have 2 of them and just have, obviously you could have a red here and a black and a red over here, and then you could have what would end up being a black that just ends up bouncing back and forth, back and forth, back and forth between the 2 red forces. You can sort of understand that that would happen, could happen. All right, so the basic point is that what we call mass shows itself or reveals itself based on movement, and the movement is based on the energy it has trapped in it. So mass is essentially potential energy. So it goes with Einstein's theory that mass is energy. And it's really just in the form of protons and electrons. That's the atomic weight. And you can add to that weight the neutron, which is a composite particle of an electron and a proton. So it already has the mass of the elemental bits. So the only elemental particles are really the proton and the electron. Now you could argue that the proton is more than one positron if you wanted to do that. You know, but there's no, I don't think, any good evidence that you can break protons into positrons, but who the hell knows, just to make the weight differential more even, and the very fact that they claim the positron exists. But I'm just saying, see, this is where you have to really have some familiarity with evidence to be able to argue any of this stuff, because they say something exists, and they say it for these really, you know, the evidence is nothing like what you think it is. So when they say the universe is expanding, all they have is the redshift argument. So if they misunderstand how redshift is produced, obviously that whole theory of expansion is nonsense, because that's all it's based on. And likewise, if you're going to talk about what constitutes a particle, an elemental particle, all they have for the existence of positrons is some idea that something that has the same charge as a proton, that is, it has exactly the same identity, moves too quickly. So if it moves too quickly to be what they think to be a proton, so if they've made some misunderstanding about how protons pass through materials and what your expectations should be, so if they made an error, then the particle doesn't really exist, and you're really just talking about a proton that's moving too fast. And that's all it is. It's not, there's no such thing as a positron. There's just a proton moving a speed you didn't think they would move, given the circumstance. So I'm just saying the evidence isn't like they have a whole pile of evidence and then they drew a conclusion. They have a little tiny bit of evidence and they draw a conclusion. So I can go back to the two-slit experiment and the whole creation of this notion of wave interference, and how it's based on just, yes, it's a very interesting output. Yes, it has some similarities to water waves in one experiment, in one isolated experiment. But if you consider the single slit and you consider the multi-slit, and you consider what you can learn from those experiments, especially the multi-slit that really is demonstrating that its image is being sent to the different locations, you can understand that this really isn't wave interference, that it doesn't have any similarity to water waves, and that it's just wrong to jump to that conclusion based on the scant evidence you have. Now you can say you have a bias. You seem to think it's the most viable explanation, but that's not what they're saying. They're saying you're an idiot if you don't believe what they believe. Just like the ether nuts, and they're so arrogant in claiming the existence of this thing that they can't demonstrate it to exist with anything called evidence, and it's just so obnoxious to be so arrogant when you have so little evidence. Now, I'm basing what I'm saying based on what the evidence suggests, in the sense that you have to explain all of the experimental results and all of the different manifestations of experiments, and I'm saying that this does it better. I think a particle model of external force, anyway, an external force model, which is called Mach gravity, is such a good explanation of gravity. I mean, it explains the sphericalness, it explains the inverse square law, it explains so much perfectly, why it looks the way it looks, why it does what it does. And the only issue it has is this issue of drag. If this force exists in the universe, then this force would have consequences. But they've applied no imagination to explaining how that problem may not be a problem. And one of the easiest ways to say, well, it's probably not a problem, is to understand that all matter isn't the same. Electrons, we can't give them a velocity that's permanent. We can't shoot an electron to the moon. It just can't be done. Or a proton. Those things by themselves can't maintain velocity. So they are eaten up by drag. So drag is a real thing. It really happens to the elemental bits. The elemental bits experience drag. But somehow when you put a nucleus together, as you put a few of these elemental bits together, an electron and protons, then you can create a mechanism that somehow can overcome that leakage. And I would argue that there's lots of ways to explain how that could happen. Now, one that I didn't really think about until like yesterday, so I might as well go into that. So yeah, this flowchart didn't go anywhere. I mean, it goes somewhere in the sense that it just recognizes that all you really have are the two concepts. So that's what I really wanted to just get to. You have force, that is the stuff moving the speed of light, all right, and you have mass. Okay, so that's all there is force and mass. So the stuff going the speed of light and the stuff trapped going some lesser speed because it's moving in some lesser straight line. Its straight lines are convoluted or squared or back and forth or in some other way retarded from doing the point A to point B thing the force is doing. The mass thing isn't getting to point B in the same amount of time. But that's all there is. There's force and there's mass. So you can just think there's force. And what is mass? Mass is just the electrons and the protons and whatever bias they have in their direction, whatever energy they've captured. And that's all there is. So there's just force moving in straight lines, and then force in electrons and protons that have momentum at some lesser speed than the speed of light. And that momentum is a net effect of everything that's influenced them, all the forces that have hit them. I really should just do the boat analogy, but maybe I'll save that for another video where we just do the boat analogy. Is a very good analogy. So I'll give you a preface, that I've started using, is that you can think of the electron and proton as empty boats, and they get filled by the universe, okay, with rowers. And they say the electron has 10 rowers, the proton has 10 rowers, and all that can happen is there's a ton of swimmers, and that's the force. That's the electromagnetic spectrum, that's the gravity, and that's the magnetism. And they're swimmers. They go into the boat, they become rowers, and they row in the direction that they were swimming. And that's basically the rule. The rule is if you want to take a new swimmer pops into your boat, you have to get rid of one of the existing rowers, and he becomes a swimmer. So all you're doing is making exchanges. They're just energy exchanges like this. And that's all that's happening in the universe. And because there's two kinds of force is the only reason why this can get very complicated. Because this can create traps. And the traps are what we call matter. Alright. So where was I going to finish up with? It's all just force and mass. So I was going to draw something else. And it's just about the fact that it has this polarity. Yeah, so that's all I just wanted to make this this relationship between these two things, so you understand when you have energy equals mc squared, all you're really saying is that in every piece of matter, something has mass, there's rowers. And if you free those rowers, put them back into the ocean as swimmers, the swimming sea gets more dense. There's more energy in it. So the matter is energy. It is swimmers. I can reduce the matter to rays of force and convert rays of force, swimmers, into rowers. Yeah, so I don't think there's much point in getting into a bunch of other stuff, but it's all just pressure. And so the matter is made of stuff that's been created in high pressure, electrons and protons, so they have high pressure in them, they have mass in them, they have force in them, they have little bits trapped in them. And you can break them and release that. Not that we know if we can break electrons and protons. They're elemental, so they're not easily broken. But you can certainly break the atoms that they turn into. The nuclei and the neutron will decay in 15 minutes into a proton and an electron. So the rest of this stuff is decayable. It's breakable. It isn't as durable, but some of it's very durable. Some of the molecules survive billions and billions of years as trapped energy. The energy just keeps going in its circles. So that's the point I was trying to make, is that the momentum velocity of matter can be more complicated because the matter can have pathways of reflection, okay, that end up creating more net momentum in one direction than the other direction because of these how they interact, and how the motion is realized. But the other argument, the insulation argument, is the one I wanted to make. Okay, that's the one I wanted to get to. So the idea is here is to understand, like the Earth is molten in the inside. Okay, it's all liquid in here. Okay, that's the theory, and it seems reasonable, because that's all the gravitational pressure. And pressure's intensely high in the center of the Earth. The chemical pressure, the amount of movement the atoms are under in terms of they're being pushed and they can't get where they're going, and so they're pushing against each other with tremendous amounts of pressure. And so that's why they're liquid. There might even be gases in there. Groundhogs. So anyway, yes, I must pause again just because I have to go see if the groundhog is destroying my garden. Alright, probably just a bird. Anyway, yeah. It's just kind of, I've been shoved into some sort of urbania, the urumburbs. I mean, houses everywhere, and you're saying, well, there's no insects, because I guess they all get killed by all the people speeding down the roads, which is funny, no butterflies or anything like that. And there's a groundhog, though, because like a neighbor has a, unkept little backyard full of junk, and so, this groundhog is living there. So he gets under the fence, and, But anyway, just kind of funny that for years I've had to, protect everything from deers, and I finally think, I'm free. No, not so free. Still blighted by the pests. Okay, so anyway, so the Earth is really, inside very, very hot. And very little of that heat actually ever gets to the surface, in a sense. So it's like insulated from change. It doesn't dissipate, a bunch of heat, because it has to go through all these layers to get to the outside. And there's so many parts of the layers are just kind of reflecting the heat back, and so all those little reflections add up to eventually insulation. And it's sort of like we can create furnaces like that, very well insulated, very little energy out, considering how much energy's in. That my argument would be is that matter does the same thing, in the sense that it can create an environment where you could have the velocity of the interior doesn't get dragged down by what's happening on the exterior. So change on the exterior has no way of affecting or diminishing or diluting what's going on the inside, because it's a protected environment, in the sense that there's no way for a piece of this internal energy to ever get there, because it always gets reflected back in. So it's constantly reflected back in, so it stays the net same thing that it was before. So it's a way of understanding that you can be insulated from friction and drag. So just another way of understanding that this isn't the critical problem they make it out to be, in the sense that you can understand that something can have a maintainable velocity if you build it right, construct it correctly. I mean, it's just like, it's just understanding that if you put a pointy end on a torpedo, it goes through the water better. It's almost that simple an argument, that there's ways to overcome the obstacle that might be in the way. And so this drag issue doesn't necessarily have to be something that's not surmountable. It's a surmountable problem. And again, I would argue that we already have indication that this must obviously be the truth, because the electron and the proton as individual entities are dragged down, because they don't have any insulation. They don't have any protection against the external world equalizing their temperature, thermodynamically forcing them to become the same as the external environment, to comply to that environment. Alright, that's probably enough. So, again, could have explained it better, but I got to the key points I think are here. But yes, it's have to, the presentation needs to be improved. But I mean, somebody who understands these just simple engineering concepts really should understand that there's I haven't cheated reality here in any way, and that this simple explanation of how the universe works, that it's just energy, and energy can have straight paths or it can have not straight paths that take it nowhere. That it can go a bunch of stuff that doesn't get it anywhere in the universe. It just always ends up back in the same place. Alright, anyway, it always restarts. Well, trap, it's just the key concept here. If you trap something, if I trap the gopher, the groundhog, then the whole life he would have had isn't going to happen. So he won't eat somebody else's garden, he won't do this, and he won't do... There's a whole bunch of implications, to me, capturing the groundhog and moving him someplace else. And the same thing happens in the universe. We all capture energy from light bulbs and this, and then we go outside and we release that energy in some other place. And we're always just diverting what's going on. What would have gone if this thing didn't exist? It makes a change being here. It just does. And it's true even philosophically in how we exist on Earth. We leave a footprint. People use the word green footprint. I use the word blood footprint. But yeah, you have an impact on the world. You can make it a better place. You can make it a worse place. You can break things or you can fix things. And that's the nature of every little elemental bit in the universe is playing that role. Just by existing, it's changing. In the sense that the universe will be different. Things will go from point A to point B if you're not in the way. Your wife would have married somebody really cool if you didn't get in the way and ruin her life. This is real shit that really happens. So anyway, enough. So, ignore the philosophy part because it's just too dangerous. But anyway, till the next time and such, I think I'm okay. So, save. We'll just save it. Okay. Alright, till next time.